Hello students, in this video we'll introduce the permutation symbol and see how we can express dot products and cross products in terms of permutation symbol in standard basis vectors. The first thing we're going to do is we're going to let the standard basis ijk be denoted by a new set, which we'll call delta 1, delta 2, and delta 3. We're just going to reparameterize how we're going to call these standard basis vectors. So what is I? The vector I is going to be delta 1. What's the vector j going to be? The j is going to be delta 2, and the k is going to be delta 3. Okay. And then we'll define delta ij as delta I dot product delta j. So put hat on that and hat on that. And so what will delta ij be? Well, if I and j are not the same, the dot product of I and j and k are all going to be 0. But if I and j are the same, if I have delta 1 dot delta 1, I'll get a 1. So this is going to be equal to 1 if I is equal to j, and 0 if I is not equal to j. Now what we can do is we can write a vector v. So if we write v, let v be the vector v1, v2, v3, can be written as the sum, j goes from 1 to 3, of vj delta j hat. This notation is very convenient in terms of doing dot products. If we let w be w1, w2, w3, this will be the sum. I'll use a different index over here. I'll say I goes from 1 to 3 of wi, and then delta I hat. Okay? Now, if we do the dot product, we can use this Kronecker symbol. So the symbol is called the Kronecker symbol. The symbol here is called the Kronecker symbol. Okay? And let's do the dot product now using the Kronecker symbol. So if I do v dot w is going to be the sum, j goes from 1 to 3 of vj delta j hat. And we're going to dot this with the sum, I goes from 1 to 3 of wi delta I hat. And what we'll get is we'll get two sums. The sum, j goes from 1 to 3. The sum, I goes from 1 to 3. So 9 things total here. I'm going to have a wi and then a vj. And then I'm going to have delta j dot delta I. Delta j dot delta I is the same as delta I dot delta j. So it's going to be a delta ij. And now when you sum over the delta function over I and j, the only time this is going to materialize is when j is equal to I. So this sum collapses because if j and I are not the same, then the Kronecker symbol will give me 0. So this is going to be equal to, I'll contract this. This is going to be I goes from 1 to 3 of wi. Then j must be I, vi, and I'll have delta ii, which will turn to a 1. And so this is our expression for the dot product. It's exactly the same expression we saw with the ordinary dot product notation. This will allow us to do way more calculations, though, if I'm able to incorporate this Kronecker symbol. Now let's define the permutation symbol. Define the permutation symbol. Permutation symbol is epsilon ijk, and this is going to be 1/2 of what? I minus j, j minus k, and k minus I, where I, j, and k range between 1 and 3. So I, j, k here go between 1 and 3. I, j, and k are between 1, they're either 1, 2, or 3. Now, if any two of them are the same, so if I is equal to j, or k is equal to I, or j is equal to k, if any two of them are equal, if two of them are equal, then this product will be 0. So it turns out that epsilon I, j, k is one of 3 values. We can check. And we can check that it's going to be equal to 1 at the values I, j, k, if I, j, k is equal to 1, 2, 3. Or if it's equal to 2, 3, 1, or if it's equal to 3, 1, 2. Okay? It will be equal to -1 if I, j, and k, j, k, are equal to the other permutations. So we could have a 3, so we have a 1, 3, 2, or a 2, 1, 3, or a 3, 2, 1. and it will be equal to 0 otherwise. Let's just do one to check. So if I plug in I equals, if this is my I, j, and k, I will have a 2 minus 3 over here, so that would be a negative 1. I would have a j minus k over here, so what would that be? So I have j, which is 3, and then I get k, which is 1, so that's going to give me a 2. And then a k minus I will be a 1 minus 2, that's a negative 1. So I have negative 1 is a positive 1, 2 is 2, divided by half, I do indeed get 1. You can check the other 6 yourself. Now we introduce this permutation symbol because it turns out that if I do delta I cross delta j, that will be equal to, what will this be equal to? This will be equal to epsilon I j k delta k. So this relationship, it gives us the relationship between I cross j, j cross k, k cross I, and the opposites of them. So this relationship is valid for the permutation symbol. Now, using this, what we can do is we can say, you can show now, and we'll see later on, that if we look at v cross w will be the sum. K goes from 1 up to 3. Vi, the sum I goes from 1 to 3. The sum j goes from 1 to 3. So let's just leave it here because the formula is going to get a little bit too messy. So let's just X the formula. What we'll do in the future videos, we'll see how we can write the dot product, and how we can write the cross product rather, the cross product with this epsilon ijk symbol. So we can use epsilon ijk to do cross products. Thank you very much.